What's up? Now I hope everyone is doing okay. We actually have quite nice weather here. We have the sun, we have a nice blue sky. Now let's ruin our day by diving into the map function. Alright, so what is the map function? Well, the map function is a powerful method that we have in Java 8 or higher. And we also see this map function in many other programming languages like Scala and JavaScript, for instance. Now this means that understanding the map function can also be beneficial when learning other programming languages. Within Java we can find the map function in the optional class and in the stream interface. So let's zoom in a bit deeper. Let's first have a look into the map method in the optional class. Now without going into too much detail, an optional is a container which may or may not contain a value. So in this example here, the integer 10 is wrapped inside an optional. And of course you can wrap many other types inside an optional. So you can also wrap a string in an optional like this, or a custom created type like this. Now we can explain a lot more about optionals, but I'll do that in an upcoming video. The main point for now is that these are examples of an optional that contains a value. And in contrast, this is an example of an optional that doesn't contain a value. Now, as mentioned earlier, in Java, we can execute a map method on an optional, and this map method looks like this. Now, if you are relatively new to programming, then this may look intimidating. However, it is relatively simple, so let's break this down very quickly. First of all, map is of course the name of this method. And then we see that this map method accepts a lambda, or in other words an anonymous function, as an argument. Now if you want a more detailed explanation how these lambdas work, I would suggest to watch the video that pops up somewhere here above, and I will also place a link in the description. Alright, so this lambda takes a value of type t as an input and produces a result of type u. Now you might think, what are these type t and type u values? Well, these are generic types, and t basically refers to the type that is inside our optional, and u refers to the type that is produced by the lambda. So this map function basically grabs the value inside our optional, and then it executes the specified lambda on that value. So we do some transformation on the value that is inside our optional, and then we return that transformed result. Now maybe this still sounds a bit fake, so let's explain this by showing an example. First of all, let's wrap a value inside an optional. So let's say something like this. Optional of hello. And then of course we need to import the optional. So now we wrap the string hello inside the optional, and let's actually catch the value in a variable, and that variable is of type optional string, and let's call it now string opt. Alright, now let's say that we want to calculate the length of the string inside this optional, and we want to store that into a new optional. Or in other words, we want to transform the value inside this optional to an integer value that represents the length of the string. Now we can do this very easily by executing the map method on this optional. So we can simply do string opt, and then we execute the map method on this optional like this, and then we can specify a function, because as mentioned this map method accepts another function as an argument. So in this case we get the value inside the optional, and then we say we want to calculate the length of this value, and we can also catch the result here inside a new variable. And now this will not be type string, but this will be type integer, and let's give it the name result for now. Oh, I made a typo here, so let's correct that. Alright, so in this case we execute the map method on the string optional. Then we get the value inside this string optional, which is hello. So the string hello refers to this t type in the map method signature. And then we calculate the length of the string like this. Now the output of this function is of type integer, so u refers to type integer. Now this here results in a new optional that contains the transformed element. So to summarize, the map method applies the given function to the element that is inside the optional, and it produces a new optional containing the transformed element. Now for that reason, the map method is also called a transformer method because it allows us to transform stuff. Or in other words, with the map method, we can transform the element inside our optional container and we return a new optional that contains the new element. Now this is one simple example, but of course we can give our map method here a lot of different methods. And one quick note is that now we execute a single line function, but if you want to apply more complex operations, then you can place the body inside curly braces like this. And then you need to specify a return keyword. And in here you can then do some other stuff. Let's do some other stuff. So yeah, this is the syntax if you want to apply more complex operations on a value that is inside an optional which doesn't fit into a single line. Alright, I hope that makes sense. So let's now dive into the map method inside the stream interface. Now the map method in the stream interface looks almost identical to the map method in the optional class, only we now return a new stream instead of a new optional. So let's first explain streams in a nutshell. Streams can be created from various sources. Now sources can be things like collections, arrays or I/O resources. Let's show an example. We can for instance convert a list to a stream like this. Or we can convert an array to a stream like this. Or we can simply initialize a stream like this. Now for a more detailed explanation about streams, I suggest to watch the video that pops up above, and I will also place a link in the description. However, the main point for now is that streams can be created from various sources. And once we have a stream, we can execute the map method on that stream. Now the map method of a stream has basically the same behavior as the map method of the optional class. So what it does is it grabs all the elements inside the stream one by one and then it executes the mapper function, or in other words, our created lambda will be executed on each element in the stream. And finally, the map method returns a new stream containing all the transformed elements. So again, let's show a simple example. Let's say we have a list of integers like this, 1, 2, 3, and let's import the list like this. And let's now convert that list to a stream. Now let's say we want to multiply each number in this list here by 2. Now then we can simply execute the map method on the stream because we converted the list to a stream, and now we are able to execute the map method on that stream. So we can simply say map, then we grab the number inside the list and then we multiply that number by 2. So inside this map method here we specify our lambda like this. So basically we grab each number inside the stream as mentioned earlier and then we simply multiply it by 2. Or in other words, each number in this stream flows through this map method and then this lambda is executed. Now the newly transformed elements are stored in a new stream. So this map method here returns a new stream that contains all the multiplied values. Now finally we need to execute the stream, and we can do that via a so-called terminal operation. So we can simply collect the result like this and then we say convert it to a list like this. Alright, so now we have a single line, but yeah, this may be a personal preference, but I think this is a bit more readable. Alright, and of course we can catch the result in a variable. And this result here now contains all the multiplied elements. So if we print this out, result, and we execute the program, then we see that the result of this here are all the multiplied numbers. So we have 2, 4, and 6 instead of 1, 2, and 3. Alright, so pretty simple, right? Now in Java 7 or lower, you probably did it more or less like this, which is equivalent of what we did in the map method. So we create a numbers list and then we add the values 1, 2 and 3 to that list. Then we create another list, then we loop through the numbers list, so this list here. And then we multiply each number by 2 and we add that to the result list. And if we execute this, then we see that this also has the value 2, 4 and 6. So if we compare both, then we see that the map method of the stream interface can help us avoid mutability and it can help us make the code more concise. Alright, now a little bit of bonus material if you like, because the map method that we just explained are similar to what we see in other languages like Scala and JavaScript, for instance. So in Scala we can create a list like this, list 1, 2, 3. And then we can also execute the map method on it. So we get the number and we multiply that number by 2. And if we execute this, then we see that this also, wait, maybe I can zoom in a bit. Yeah, so then we see that this also returns the values 2, 4 and 6. So this also returns a new list containing the transformed elements, and notice that in Scala we don't have to specify a terminal operation. Now in JavaScript we can more or less do the same. We can create an array which we give the values 1, 2 and 3, and then we can execute the map method on it. We get each number and we multiply each number by 2. And if we store this in a variable like this, const result, and we log that result like this, then we see that we also get the values 2, 4 and 6. So if you understand the concept, then this can also be beneficial when learning other programming languages like JavaScript or Scala, for instance. Alright, so that was it. I hope you enjoyed the video and I see you guys in the next one.